The capital city, Sydney, and the city of Newcastle, 100 miles to the north, are connected by the Pacific Highway, which even with improvements is becoming progressively less able to accommodate the increasing volume of traffic between the two cities. To relieve this situation, the Department of Main Roads, New South Wales, has long-range plans for a high-standard freeway. This is to be constructed progressively as plans and funds become available. Sections of the proposed freeway, north of the Hawksbury River to Girder and south of the river to Girder, were completed as separate works by the end of 1968. However, it was necessary for the freeway traffic to rejoin the highway and cross the Hawksbury River by the old Truss and Girder Bridge, which had served since 1945. The next step was to construct a major bridge across the wide, deep waters of the river to connect the two completed sections of freeway. Over 2,000 feet long and providing 6 traffic lanes, the bridge comprises 12 steel trough girder spans, supported on 2 abutments and 11 piers. The northern abutment is founded on 3 vertical board piles. The pier, near the water's edge on the southern bank, is supported on a concrete footing cut into the rock, while the southern abutment is anchored into the top of a steep rocky slope. The 10 river piers are founded on piles driven to bedrock. Each pier is supported on 8 piles, sloping at 1 in 10 to the vertical. The inner 4 piles slope east and west, and the 2 outer piles on each side slope north and south. This gives the pier increased stability in both directions. Composite piles were used for 9 of the river piers. Each pile comprised a tubular steel section and a top section of pre-stressed concrete. The concrete pile sections were designed to extend through the salt water up to 66 feet deep and for 40 feet into the riverbed to prevent corrosion of the lower steel sections. Work on the new bridge commenced in November 1969 when a contract was let to John Hollands Proprietary Limited for the construction of the foundations. The 3 vertical steel-encased piles at the northern abutment were bored 220 feet to reach solid rock. The piles were socketed into the rock, cleaned out, reinforced and filled with concrete. Steel tube for the lower sections of the composite piles were manufactured by Humes Limited in factories at Rydalmere and Regent's Park. Heavy steel plate was rolled in stages to form a segment 30 inches in diameter and 10 feet long. Edges were then clamped and a root weld done manually. The seam was then fully welded by the submerged arc process. The ends of the segment were trimmed and beveled. Finally, the 10-foot segments were welded end-to-end into 40-foot lengths. After delivery to the bridge site, these 40-foot lengths were welded together to form tubes up to 120 feet long. These piles were then driven from platforms supported on temporary piles jetted into the riverbed. The concrete section of each pile was formed with a short steel tube spigot cast into one end. A steel mould was used to form the section, which was made hollow by casting concrete around a tubular cardboard core. After tensioning the pre-stressing wire strand, steel hoops were positioned along the pile section. The mould was closed and concrete poured under intense vibration through the slot running the length of the mould. Overnight steaming of the concrete accelerated the normal gain in strength to 4,000 pounds per square inch. The pre-stressing wires were then cut, the pile marked by the superintending officer, and the product lifted clear of the mould. The 60-foot-long pre-stressed concrete sections weighed 22 tons and were manufactured at the EPM factory, Blacktown. They were delivered 36 miles by road transport to the Hawksbury River site. The concrete pile sections were transferred to pontoons in the river and towed to the platforms at the pier positions. A floating crane hoisted the heavy sections into position in the pile leaders. The concrete and steel sections of the piles were carefully mated and welded together. This weld took 2 operators 3.5 hours to complete. A diesel pile hammer with a 4-ton ram drove the composite piles to bedrock. At the Pier 5 location, piles were driven to a record depth of 279 feet below mean tide level. To prove the capacity of the piles to support the design load, one pile was subjected to a test load of 500 tons for 24 hours. At the steeply sloping bank on the southern side of the river, Pier 2 required board piles, similar to those at the northern abutment. Driven down and socketed into solid rock, the piles were cleaned out, reinforced and filled with concrete. After the completion of the 8 piles at each pier, the tops were trimmed to level. Precast concrete units forming the base to the pile cap were then placed and concreted into position. Steel reinforcement was fixed and steel formwork erected. Concrete was then pumped and vibrated into the forms to complete the pile cap. Following completion of the foundations, the Department of Main Roads invited tenders for the construction of the superstructure of the bridge. The successful tenderer was the Hornibrook Group, and work on this contract commenced in February 1971. Work on the pier columns proceeded simultaneously with construction of the north and south abutments. Concrete for the piers was discharged into skips and placed by floating crane. After each lift of concrete was placed, the top surface was roughened by an air and water jet. To span the finished piers, 36 open trough trapezoidal steel girders would support the concrete deck. They were manufactured by John Lysart Australia Limited at their Newcastle engineering shop. Most of the girders were 180 feet in length and were manufactured in 3 equal sections. Fabrication commenced in the upside-down position for ease of welding. The partly completed section was then turned over to complete the welding work. After protective treatment by grit blasting, hot zinc spraying and shop painting, the 27 tons, 60-foot long sections were transported 77 miles by road to the Hawksbury site. Splicing together of the 3 60-foot girder sections was done on site by a small team of specialist welders. The girder sections were placed on stools to facilitate matching alignment and welding. The operations of lining up the 3 sections, careful matching, welding of the 2 joints, and the completion of all fillet welds on the internal stiffeners occupied a minimum of 9 days for each girder. The important bottom flange weld and other selected welds were examined radiographically to confirm the quality of the finished work. Expansion joints were built into the girders in spans 7 and 12 and temporarily fixed. After erection and stressing of the concrete deck sections in those spans, the girder joints would be cut to free the action of the rollers. The completed girder, weighing 84 tons, was launched from a specially constructed jetty. For the erection of the girders, a large timber pontoon was fitted out with twin 70-foot lifting towers made of Bailey Bridge components. This erection pontoon was used to place 33 of the 36 girders into position on top of the pier columns. At the southern end of the bridge, the 3 90-foot girders in span 1 were placed into position using an aluminium erection truss. The 7.5-ton truss was cantilevered out 90 feet to supports on top of the Pier 1 columns. The girders were winched along the truss and lowered into position by hydraulic rams. As skill was developed in handling the 84-ton girders, the contractor was able to pick up a girder, transport it across the river and position it on the pier tops within a period of 2 hours. The first of the 3 girders to close the gap across the last unfinished section of the bridge was placed in position on the 8th of December 1972. with the completion of the girder erection, the many major challenges of the 2,000-foot crossing had been met successfully. Formwork for the deck concrete was erected and oiled, and the next step was the placement of reinforcing steel. Concrete for the deck was delivered by agitator trucks and pumped into position. The largest single pour was 260 cubic yards, placed at the rate of 30 cubic yards per hour by a team of 12 men. The concrete deck over each pier was stressed longitudinally with 90 1 3/8-inch diameter high tensile macalloy bars, and also stressed vertically into the pier columns. Following construction of the curbs and median barrier and the erection of crash railings, only painting remained to complete the contract work. The crash railings were finished in white gloss enamel. By contrast, the final colour selected for the girders was forest green. Extensive earthworks were required to form the approaches to the new bridge and to merge the new carriageways into the existing sections of the freeway. A 2-inch thick asphaltic concrete surface was laid by the department's own labour and equipment. The surfacing machines worked to fine tolerances to provide a riding surface of high standard. On August the 10th, 1973, the Minister for Highways and Local Government, Sir Charles Cutler, accompanied by the Commissioner for Main Roads, R.J.S. Thomas, opened the bridge to northbound traffic at a short ceremony at the southern abutment. Three police minicars then led the first of the traffic northwards across the new bridge. The completion of work to enable the switchover of traffic lanes that previously served the old Pacific Highway Bridge meant that southbound traffic was not able to use the new bridge until October the 26th. After 4 years of concentrated work, the last link has been forged connecting the sections of Freeway north and south of the Hawksbury River. This gives the motorist an uninterrupted 16 miles from Girder to Girder. While introducing original and ingenious concepts in piling and steel box girder construction, the designers combined the most modern techniques in bridge building with proven methods for reinforced and pre-stressed concrete construction. The structural lines resulting from this design are clean and eminently practical, providing flat exterior surfaces which greatly simplify maintenance. As an example of modern bridge construction, it stands as a tribute to the engineers of the Department of Main Roads, New South Wales, who designed the bridge and supervised the work, and to the contractors who successfully overcame the difficulties of the site and the many challenges of construction.